Hi, everybody. It's Professor Mitchell continuing with Chapter 1. Today we're looking at Section 1.3 on the intersection point of a pair of lines. In this section, we will solve systems of the form y equals mx plus b and y equals nx plus c. We'll solve equations of the form y equals mx plus b and x equals a. And finally, we'll talk about supply and demand curves. All right, so first, to solve a system of the form y equals mx plus b and y equals nx plus c, in other words, to determine the coordinates of the point of intersection of those two lines, we will set mx plus b equal to nx plus c and solve for x. This will give us the x coordinate of the point. And then we'll substitute the value obtained for x into either equation and solve for y, and this will be the y coordinate of the point. So as an example, let's look at the system 2x plus 3y equals 7 and 4x minus 2y equals 9. Now, we will talk about a different way of doing this when we get to Chapter 2. But for now, what we're going to do is solve both of these equations for y, starting with 2x plus 3y equals 7. So first I'll subtract 2x from both sides, which will give me 3y equals negative 2x plus 7. And then I'll divide everybody by 3. All right, so the first equation solved for y is y equals negative 2/3 x plus 7/3. And now I'll do the same thing with the second equation, 4x minus 2y equals 9. We'll subtract 4x from both sides, which gives us negative 2y equals negative 4x plus 9. And then we'll divide everybody by negative 2. Watch those signs. So this equation solved for y is y equals negative 4 divided by negative 2, which is positive 2x, plus 9 divided by negative 2, which is minus 9 halves. So this is my first equation solved for y. This is my second equation solved for y. So now what I'm going to do is set negative 2/3 x plus 7/3 equal to 2x minus 9 halves. So that's negative 2/3 x plus 7/3 equals 2x minus 9 halves. All right, so I know that fractions are not everybody's favorite thing, but we might as well get used to them because we're going to be seeing them a lot in later chapters. So the way I recommend dealing with this is to multiply both sides of the equation by the LCD, the least common denominator, which for this equation would be 6. I'm going to take this nice and slow in this example, and then as we get more and more practice with the fractions, you'll see me doing them a little bit faster each time. Okay, so parking a 6 in front of each of these terms, or next to each of these terms, we have 6 times negative 2/3 x plus 6 times 7/3 equals 6 times 2x minus 6 times 9 halves. All right, here we go. So 3 goes into 6 2 times. 3 goes into 6 2 times. And 2 goes into 6 3 times. So when we clean up this equation, it turns into something a lot nicer, which is negative 4x plus 14 equals 12x minus 27. All right, so now I need to get my x's on one side. Might as well go with the left side. And get the numbers on the other side. So I'll go minus 14 on both sides. So that's gone. This is gone. And I'm left with negative 16x equals negative 41. Dividing both sides by negative 16, we find that x is positive 41 over 16. All right, so now we need to substitute that value of x into either one of the equations that we got when we solved for y. I think I'll go with the second one, y equals 2x minus 9/2. So that'll be y equals 2 times 41 over 16 minus 9/2. 2 goes into 16 8 times. So y equals 41 over 8 minus 9/2. I need a common denominator, which would be 8. So I'll multiply the top and the bottom of this one by 4. And that'll give me y equals 41 over 8 minus 36 over 8, which is 5/8. All right. With barely any room to spare, the solution of this system of equations is 41/16, comma, 5/8. And if you were to graph these two lines, you would find that the graph looks like this. So 41 over 16 is somewhere between 2 and 3. 5/8 is somewhere between 0 and 1. I teach some classes where we talk about solving systems of equations by graphing the lines. This is a great example of a system where you would not want to do it that way, because graphing these lines, you would be really unlikely to be able to tell exactly what that point of intersection is. So it's definitely best to do it algebraically like we just did. All right, so now we'll talk about solving systems of the form y equals mx plus b and x equals a. That's actually easier than what we just did. To determine the coordinates of the point of intersection of these two lines, we're going to, first of all, we have the x coordinate. The x coordinate has to be x equals a, and that's because the point of intersection, the x and the y, have to solve both equations. So remember, a is going to be a specific number, say 2. So if one of the lines is x equals 2, then the point of intersection of that line with any other line has to have an x coordinate of 2. And then you just take that value of x and substitute it into the other equation and solve for y to get the y coordinate. So for this example, we will find the point of intersection of the lines y equals 2x minus 1 and x equals 2. And as I said, this one ends up being much, much simpler. For one thing, this equation is already solved for y, so that's nice. We know that the answer is going to be 2 comma something, because one of the equations is x equals 2. To figure out what that y coordinate is, just substitute 2 for x into this equation. And that gives me y equals 2 times 2, which is 4, 4 minus 1, which is 3. So the point of intersection of these two lines is 2 comma 3. Maybe we should have done that one first. All right. And there's the graph of those two lines. All right, so that brings us to supply and demand curves. For every quantity Q of a commodity, the supply curve specifies the price P that must be charged for a manufacturer to be willing to produce Q units of the commodity. And for a demand curve, for every quantity Q of a commodity, the demand curve gives the price P that must be charged in order for Q units of the commodity to be sold. So what we're usually interested in finding out is what is the price that should be charged for a commodity so that the supply and the demand are equal. If your demand exceeds your supply, then that means the commodity sells out and there's people that would have been interested in buying it that can't buy it. On the other hand, if your supply exceeds your demand, then you have a bunch of that product left over that doesn't sell. So the ideal situation is find the quantity and the price for which supply and demand are equal. For example, suppose the supply and demand for a quantity, the supply is given by P equals 2 10,000ths Q plus 2, where P is in dollars, and P equals negative 5 10,000ths Q plus 5 5/10. Determine both the quantity of the commodity that will be produced and the price at which it will sell when supply equals demand. All right, so let's go over to the tablet. And I didn't write out this whole, the whole paragraph, just the important part. So this is like our first example, only instead of X and Y, we have Q and P. So we can set this and this equal to each other. 2 10,000ths Q plus 2 is equal to negative 5 10,000ths Q plus 5 5/10. So we just need to put the Q terms on one side. I'll put them on the left side. And then put the constant terms on the other side. All right, so that's going to go, and that's going to leave us with 7 10,000ths Q equals 3 5/10. So now dividing both sides by 7 10,000ths. We get Q equals, okay. Now, here comes one of my Mitchellisms. It's called Don't Be a Hero. People are really, really bad at doing decimal arithmetic in their head. And in this case, I'm going to include myself in that statement. So either do this on the calculator and make sure that you put in the correct number of zeros, or at the very least, what I'm going to do is, let's see, if I move this decimal point 1, 2, 3, 4, move this decimal point the same number of places, 1, 2, 3, 4, which makes this the same as 35,000 divided by 7. And now I can tell that answer is going to be 5,000. Okay. All right. So what we know so far is that if 5,000 units of this commodity are produced and sold, then the supply will equal the demand. So now we just need to know what is the price that corresponds with that. So I'll substitute that value of Q into one of these equations. Let's say the first one. P equals 2 10,000ths Q, and I'll go ahead and substitute 5,000 for Q, plus 2. All right, so I believe if you do the math, 2 10,000s times 5,000. Oh, well, that has to be 10,000 over 10,000. So that comes out to 1. 1 plus 2 equals 3, as in $3. Okay, so the moral of the story is that when 5,000 units are sold for $3 each, supply will equal demand. So everybody that wants this product will get it, and I won't have any left over. All right, and that brings us just about to the end. I just want to show you, again, if you're in my class, you are welcome to do one of these problems for the discussion. All right, and then the summary of this section: the point of intersection of a pair of lines can be obtained by first converting the equations to standard form, y equals mx plus b, and then either equating the two expressions for y or substituting the value of x from the form x equals a into the other equation. That's going to do it for section 1.3, and I believe that's going to do it for chapter 1. So we'll see you next time.